Hello, we are Fitrisina Azzahra Nurdiansyah and Aquilani Nafisa Nurdiansyah dari Taruna Bakti Junior High School Bandung, Indonesia. Imagine a brick that's stronger, cooler and kinder to the planet, made without a roaring kiln or clouds of smoke. That's the promise of GeoAsh brick. We start from two problems that touch every city: the carbon footprint of traditional fired clay bricks and the mountains of plastic waste that outlast generations. Instead of treating them separately, we weave them into one solution, using the power hidden in our own backyard: volcanic ash. At the heart of GeoAsh brick is a geopolymer binder. Volcanic ash, rich in reactive aluminosilicates, is activated with a carefully balanced alkali blend, sodium hydroxide and sodium silicate, to form a stone-like network at room temperature. Into this matrix, we introduce finely milled recycled plastic as reinforcement, helping to improve toughness and reduce density. We also incorporate a small fraction of biochar, around 5 to 10%, to tune porosity and dampen heat flow through the brick, enhancing thermal comfort in finished buildings. The process is simple by design. We measure, mix, and mold. The fresh mixture flows into straightforward molds, wooden jigs, or even 3D printed forms, then cures at ambient conditions. No kiln, no fossil fuel feast. Just chemistry doing quiet work while energy consumption stays low and emissions shrink. Safety guides every step. We work in well-ventilated spaces, wear gloves and eye protection, and handle alkalis with respect. Any residual alkaline solutions are neutralized before disposal because a process that calls itself eco-friendly must protect the people and places making it possible. Performance matters, so we test. For compressive strength, we load the bricks gradually and watch the numbers climb, aiming for that sweet spot of 8 to 10 megapascals or more, robust enough for a wide range of non-structural and certain structural applications, depending on local codes. We track water absorption by measuring mass before and after a 24-hour soak, targeting at least a 20% reduction compared with standard reference bricks to improve durability in wet conditions. And for thermal behavior, we compare temperature differences across samples, working toward a meaningful drop in thermal conductivity, on the order of 10%, to help indoor spaces stay naturally cooler. Beyond the lab, we run a simple mini LCA, an environmental checkup that compares energy use and estimated CO2 with conventional kiln-fired bricks. Removing the firing stage is a game changer: less energy in, fewer emissions out, and a second life for plastic that might otherwise clog rivers or smolder in open piles. But the true strength of GeoAsh brick is accessibility. This is a low-tech process that schools, vocational centers, and small manufacturers can learn and replicate with locally available materials and modest equipment. Imagine students transforming ash and waste into climate-smart building blocks. Imagine small workshops producing affordable, cooler-running bricks for homes, classrooms, and clinics. GeoAsh brick turns what we have: volcanic ash, plastic waste, and human ingenuity into what we need: resilient, lower carbon materials that build comfort as well as walls. One brick at a time, we can shape cities that breathe easier, waste less, and welcome the future.